Hello students, welcome to my YouTube channel. I am Vishwanath. Today's topic of discussion is Coulomb's law about magnetism. You know that a bar magnet has two poles. One is north pole and another is south pole. An isolated magnetic pole is only assumption. In practice, no isolated magnetic pole is situated. You know that two like poles repel each other. Here, two north poles repel each other. On the other hand, a north pole always attracts a south pole. That is, two opposite poles attract each other. You know that a magnet can attract iron, cobalt, nickel, etc. But repulsion only occurs between two like poles. In this case, two south poles repel each other. That's why we can say that repulsion is the surer test of magnetism. If you like my video, then please click the like button and please subscribe my channel. Let's watch the Coulomb's law about magnetism, its mathematical derivation, magnetic field strength, and unit pole. Let's watch the video. This is Coulomb's law about magnetism. Let capital A and capital B, the two isolated magnetic poles having pole strength M1 and M2 respectively. You know that the isolated magnetic pole is ideal one. Practically no isolated magnetic pole is found. Capital small r is the distance between these two poles. If these two poles are same in nature, then they repel each other. If they are opposite in nature, then they attract each other. Capital F is the force of attraction or repulsion between them. Now the value of F or magnitude of F depends on the product of two pole strengths and the distance between two poles. Now capital F is directly proportional to m1, m2, and F is inversely proportional to the square of the distance between them. That is, if the pole strength of two magnetic poles increased, then the force between them also increased. If the distance between them is increased, then the force between them will be decreased. Therefore, in mathematically we can write first F proportional to m1 m2 and second F proportional to 1 by r square. This formula is quite similar to the Coulomb's law about electrostatics. From the above two laws, we can write that F proportional to m1 m2 by r square. Therefore, F is equal to mu0 by 4 pi m1 m2 by r square in CGS system when the experiment is conducted in air or in vacuum. That is, the medium is either in air or vacuum. Here mu0 is the magnetic permeability of air or vacuum. If the experiment is conducted in other medium, then the law will be F is equal to mu by 4 pi f1 f2 m1 m2 by r square. F is equal to mu by 4 pi m1 m2 by r square, where mu is the absolute magnetic permeability of that medium. Now mu r is equal to mu by mu 0 is the relative magnetic permeability of that medium with respect to air or vacuum. Mu 0 by 4 pi has standard value 10 to the power minus 7 in SI system or SI unit. Now we are going to discuss about unit pole. When two same poles having same pole strength and equal in nature are placed at a distance 1 meter in air, and if the force or repulsive force between them is 10 to the power minus 7 Newton, then each pole is considered as unit pole. That is, from Coulomb's law we know that F is equal to mu 0 by 4 pi m1 m2 by r square. Here m1 is equal to m2 is equal to m. Therefore F is equal to mu 0 by 4 pi m square by r square. Now putting F is equal to 10 to the power minus 7, mu 0 by 4 pi is equal to 10 to the power minus 7, r is equal to 1 meter. We have m square is equal to 1. Therefore m is equal to plus minus 1. That is, m is unit magnetic pole. The unit of magnetic pole is ampere meter. Unit of magnetic pole strength is ampere meter. Now magnetic field strength. Let an isolated magnetic pole is placed at a point A and its pole strength is m. O is a point in air at a distance r. Now unit north pole is placed at the point O. Now the force experienced by the unit north pole at the point O is known as magnetic field strength at that point O due to the isolated magnetic pole M. Now from Coulomb's law we know that F is equal to mu 0 by 4 pi m1 m2 by r square. This whole experiment is conducted in air. Now m1 is equal to m and m2 is equal to 1 and F is equal to B. The magnetic field strength is denoted by capital B. Therefore B is equal to mu 0 by 4 pi m by r square. In vector form we can write B vector is equal to mu 0 by 4 pi m by r square into r cap, where r cap is the unit vector of r vector, and we know that r cap is equal to r vector by magnitude of r. Here r denotes the magnitude of r vector. Therefore we can write that B vector is equal to mu 0 by 4 pi m by r cube into r vector. This is the mathematical expression of magnetic field strength. Now we are going to establish the relation between magnetic field strength and the force on a magnetic pole. Let another isolated magnetic pole is placed at the point O. Its pole strength is M prime. Therefore, the force between M and M prime is F is equal to mu 0 by 4 pi M prime by r square. You know that B is equal to mu 0 by 4 pi M by r square. Therefore, F is equal to B into M prime, or F vector is equal to B vector into M prime. That is, force on a magnetic pole is equal to magnetic field strength into pole strength, magnetic pole strength. This is the relation between magnetic field strength and force.